Okay, so here we are solving the second question. Okay, um, so the second question, they tell you in flies, 3 autosomal genes have the following map distances. So they already gave you the map distances. What they want you to do is to work backward and find the different phenotypic classes. Okay, and then they said, suppose that that's how it originally looks like. The suppose that these females are crossed to homozygous ABC male. So you know that the parental group, the originally, especially for the females, it's gonna look like this. So you're gonna have A plus C, and B is entranced to those two. Okay, so you already know that. So what this is showing you is showing you A, C, and then they're showing you plus B, like the wild type for the B, trait. So what they want you to find, out of the 1,000, where was it? Did they say it was 1,000? Yeah, so out of the 1,000, how many of them were parental groups? Okay, how many of them were double crossovers? And what are the numbers for both single crossover 1, where A is the only one that crosses over, or single crossover 2, where it wasn't A that crossed over, it was actually C that crossed over. Actually, for me too. Yeah, C is the one that crossed over. Okay, so that's what they want you to find out. The number out of the 1,000 flies, how many of them were parental, how many of them were double crossovers, single crossovers, or for A, or single crossovers for C. And they already gave you the map distances. So in this case, what they really want you to do is work backwards. So what's your relative frequency equation? Your relative frequency equation is as follows, right? It's single crossover plus double crossover over total times 100. Okay? In this case, you know what your total is equal to. Your total is equal to 1,000. Okay? You know your relative frequencies. Your first relative frequency, because this is RF1 and this is RF2. So you know the values for your relative frequency. The values that you don't know are the single crossover for each one and the double crossover. Okay, once you figure those out, you can do everything else. So for you to have, so the first number we can figure out is this one, the double crossover number. For you to have a double crossover, what do you have to have? You have to have A crossing over, right? And you have to have C crossing over at the same time. So let's look at this. Oops. Okay, so you have to have, again, you want A to cross over, and you also want C to cross over at the same time to have a double crossover, because your double crossover looks like this. A goes down and then comes back up to C. So you have to have this side crossing, and then at the same time you have to have this side crossing. So you use the word and, right? A crossing and C crossing. You want A and C crossing. So when we work with probabilities, when we see the word and, it means we multiply. Okay, so what's the probability for a single crossover in A? You get this number, so it's 15. What's the probability for a single crossover for C? This one, 10. So your double crossover is equal to 15 times 10. Okay, and I'm sorry, this here, your mu, if you have 1 mu, it's equal to, you divide that one by 100. Oh, sorry, it's equal to 1%, 1 relative frequency percent. Okay, so, and numbers are percent are actually 1 divided by 100. So this one, it's supposed to be divided by 100, because I forgot to tell you that part. So it's those two frequencies. So your answer would be 15 over this, which is 0. Why am I spacing out again? Yeah, 0.0015. Why do I have a feeling I did something wrong? No, that's right. So it's 0.0015. Okay, so that's your frequency. So you multiply this number, because, okay, so that's the probability for the double crossover. This is probability for double crossover. So if you want the number for double crossover, the number, you take this and multiply it by 1,000. So 0.0015 multiplied by 1,000, okay, will give you, I did do something wrong. Let me try and do this again. Times oh my god, yeah, I realized what I did wrong, sorry. It's 0.015. Okay, if you use the calculator, you get the right answer. I forgot that if I take this and take this is going to be 0.1 times 0.15, and then it's going to be 0.015. That's what you do when you're spaced out and you're doing math. Anyways, so the answer here is going to be 0.015. Multiply that by 1,000, and you have 15. So your double crossovers is 15. Okay, so for double crossover I have 15, and don't forget to write this on the side for you to figure out what is the combination for double crossover. You have to look at this. So if I have a double crossover, I'm going to have A, B, C. So A, B, C, and the other possibility is going to be all wild types. So A, B, C and wild type. These two, total number for these two is going to be 15. Okay, so that's something that, so that's for my double crossover, 15. So I know the number for my double crossover. So all I have to do is plug everything into the equation and just start solving. Okay, I'll solve for 15 the first time. So when it's 15 equal to, I don't know my single crossover for this one, plus, and this 15 represents the when A crosses over. So when A crosses over, A is the only one that crosses over, I'm gonna get A, B wild type, right? So it's A, B, and the other possibility is gonna be C wild type, so it's and C. So this is my first single crossover. Okay, so for this one, 15 equals a single crossover, which I don't know the number for, plus 15. I figured out that my double crossover is 15, remember, over 1,000 times 100. So those go away. 10 multiplied by 15 is 150 minus 15. So this will lead to 85. So if you work it out, you're going to find that the single crossover is equal to 85. So this, my first crossover, that would be A, B, and C, is going to be 85. This is my single crossover. Anyways, my first one. And then for my second crossover, right? And I use this relative frequency number. It's gonna be, again, let me check for this one. So for this one here, okay, it's gonna be for the distance between C and B. So when C is the one undergoing the crossover, so when the C crosses over, I'm gonna get CB. So I'm gonna get CB, and the other one is gonna be A plus plus, so it's gonna be A. This is my other single crossover, and the number for this single crossover is gonna be found by substituting this in the equation right here. So it's gonna be 10 equals to my second single crossover plus 15 over 1,000 times 100. This goes with this. 10 times 10 is 100. Oh, 150 minus 15. Oh my god, I'm so sorry. It's 135. It's because I knew the answers from before, so I'm just, if you remember how we did it in the homework, I just remember the answers from before, a long time ago. But I apologize for that. So 10 times time is 100 minus 15. It's gonna be equal to 85. Okay, so let me erase this. It's the worst time for the pen to stop working. Let me pause this for a sec. It's not pausing. Managed to make the pen work again. Anyways, so 135, and here it's gonna be 85. This is my second crossover. But see, I figured out the numbers. Wait, there's some, yeah. So this is my first single crossover, this is my second crossover, right? And this is my double crossover. What about my parental group, which has AC in it? It has B on its own. By looking at this, I know it's going to be AC and B on its own, right? There is your AC, and here's B on its own. So to find the parental groups, it's actually 1,000 subtracted by, what are the two single crossovers I have? 135 plus 85 plus 15, right? This and this is like 100 plus this one is 235. 1,000 minus 235 is gonna give me 800 minus 35, 765. So this is the answer for my parental group. Anyways, it took me a while to explain it, but it's because I'm explaining it. But if you practice this on your own, you're gonna do it really fast on your own, and you're gonna solve it in the exam right away. But you know how we did it, right? We needed to use this equation. We had most of the data for this equation except for the double crossover. The double crossover, the way to find it is to remember that these are actually, you're supposed to get them in percentages, right? Because 1 mu equals to 1% relative frequency. Okay, so that means 10 mu is equal to 10%, right? And to get the number back to normal, it's 10 divided by 100, right? So So you'll get this to be 0.1. So when you convert these two numbers back to their original point numbers, like decimal places, instead of having them in percentage, you have them in decimal places. You multiply both the numbers, and then once you get that decimal place numbers, you multiply it by the total. Right? That's how you get your double crossover. You multiply these two numbers when they're in decimal form, and then you multiply it by the total numbers you have, and that will give you your double crossover. Once you have your double crossover, you just substitute it here. You have all the other numbers, and you solve for single crossover. Sorry about that. And you solve for single crossover, and that's how you find it. Very simple, very easy. Try it on your own, and you'll find that it's easy. Thank you.